This looks like quite an ordinary forest, and so it is. But this area wasn't always forest. It was once a sandy beach. The series of events which reached its climax as this beech maple forest is an example of a process of change in nature called ecological succession. The process of ecological succession, in different forms and at various speeds, goes on endlessly throughout the world. In the sand dune area on the southeast shores of Lake Michigan can be observed a classical example of one variety of succession which took place over a period of several thousand years. The principles involved in this example can be applied to many other situations. This succession story starts with a lake. Sand is brought in by currents from the lake. Drift from the surface of the lake is washed ashore. The middle beach is formed. The pioneer grasses get a toehold. Then come the cottonwoods, and in succession, the pines, the oaks, and finally, in this instance, the climax forest, the beech maples. Much of the sand in the dunes of the southern Lake Michigan area has been eroded from the western shore of the lake. The sand is carried by currents across the lake to the dune area. On any sunny day, especially after a summer storm, and if the winds are favorable, we can clearly see the drift near the water's edge. Drift is made up of anything that can be washed or blown ashore. Animals such as these readily decompose. Flesh flies lay eggs in the dead carcasses. The larvae that hatch will feed upon the flesh, hastening its decomposition. In the drift, there is evidence of a variety of cycles of life, death, and decay. Things that die and decay later form what is called humus. When humus mingles with sand, the slow process of biological soil making is underway. Relationships between living things begin to be established. The spotted sandpiper feeds on maggots that hatch from the eggs of the flesh flies. Beyond the reach of the waves lies the middle beach, dry and desert-like. Only such hardy creatures as the ant and the tiger beetle can survive the heat and aridity. Pioneer types of vegetation begin to gain a foothold. Many decades may pass before enough organic matter or humus is mixed with the sand to support even this sparse vegetation. Only the best adapted plants have roots that will hold in the sand against the wind. Their stems and leaves slow the blowing sand. The first small dunes are forming, the foredunes. Such creatures as the grasshopper and the lizard find here food and some protection from the elements. Hardy ants aid in soil building. The color of the wolf spider not only reflects the light and heat, but makes it less visible to its intended prey and to its enemies. As roots, leaves, and animals decay, humus accumulates and soil building continues. When there is enough moisture and enough soil to hold and nourish larger roots, cottonwood seeds may develop into seedlings. This is the beginning of the cottonwood stage of the succession. Other plants also appear. The shade and the humus help preserve the moisture in the soil. The plants are helping to create a new climate beneath their boughs. This new climate makes possible different forms of life. In a still sandy spot, a mutilid wasp, more commonly known as a velvet ant, may find a home. Nearby, a predator member of the cottonwood community, a species of tiger beetle, has made a hapless fly his prey. The antlion builds traps into which insects may fall. This is a digger wasp. Each stage of an ecological succession is characterized by certain animals, as well as by certain plants. They're called index plants and animals. Such an index animal of the cottonwood stage is the digger wasp. In this unusual scene, we see a digger wasp actually digging a hole in the sand in which to lay its eggs and bury its prey for its larvae to eat. The things they store in their burrows contribute to the accumulation of debris below the surface. This is an important step in soil building. The six-lined skink, commonly called a lizard, has caught a grasshopper and darts for the protection of a wild cherry tree, one of the characteristic plants of the cottonwood stage. The shade of the cottonwoods has conserved enough moisture and enough soil has now been formed so that the pine seedlings can take root. This area is in transition from the cottonwood to the pine stage. There is a better covering of humus-forming and moisture-building leaves and thatch on the floor. The plant and animal community is becoming more complex as we go farther and farther from the lake. This community will support some of the larger mammals, such as the deer. It will also support other animals that are dependent upon flowers and leaves, the bumblebee, the caterpillar. As the pine trees made their appearance among the cottonwoods, so now in turn the pines die, and in succession are replaced by the oaks. The oak seedlings are at first protected by the pines and are nurtured in the soil produced in part by the pines. As the transition proceeds, the oaks may entirely replace the pines. The protecting shade of the oaks helps provide an environment suitable for a host of new plants and animals, which through the years have become adapted to more soil moisture, higher relative humidity, and more humus. A fallen log provides a succession story. When a tree dies, a succession of events begins, leading inevitably to the return of the tree to the soil and to the atmosphere from which it came. Many creatures aid in the destruction of the log. Earthworms not only help destroy logs, but also take over some of the earth-digging activities which digger wasps performed in earlier stages of the succession. Centipedes do not feed upon the log, but prey upon other creatures, thereby helping to maintain a balance in nature. The log provides a habitat for many cutting, boring, and chewing creatures which eventually completely destroy their habitat, and the log again returns to the soil. The increased humus and moisture make possible an increase in the ant population. The ant is adapted to a wide variety of environments. The oak canopy above provides shade in which fungus plants thrive. The Polygyra snail has become adapted to a damp environment. It moves slowly, but is protected by its shell. There are many varieties of beetles in the oak forest. Here, for example, is a lysid beetle, a close relative of the firefly. The carabid is another of the many kinds of beetles of the oak forest. The litter and debris of the oak forest floor provide places where certain reptiles, such as the carnivorous decay snake, can search for prey, principally earthworms, and daddy longlegs, when he can find them. Another carnivore is the fox snake. It feeds principally on rodents. The skunk always moves in a leisurely manner. The oak forest provides food and shelter for a variety of tree dwellers. There are the mammals, such as the gray squirrel, which often feeds upon the floor, even though it nests in the trees. Another mammal is the opossum. These animals exist in the oak forest, which is but a short distance from the desert-like middle beach, an earlier stage of the succession. The shade and humidity increase as the growth of the trees becomes more dense. In time, the oaks die, and as conditions become right, the oaks may be replaced in succession by the beeches and maples. The trees in the beech maple forest grow tall and straight. The forest floor gets scant light, so very little underbrush can survive beneath the trees. Consequently, insects, dependent upon the underbrush for shelter and breeding places, are scarce. With decreased wind movement, the moisture content of the soil increases. And most characteristic is the increase of the true forms of the forest floor, those things which must have shade and considerable moisture to survive. The millipede is common here. It is an index animal of the beech maple forest. Another index animal is this red-backed salamander, which finds the beech maple forest an ideal place to lay its eggs. The polygyrus snail is especially abundant in the beech maple forest. It feeds principally upon molds and vegetation. The snail and box turtle are slow movers. Their shells help protect them from their faster-moving predators. In the climate of this area, the beech and maple community, once established, continues to reproduce indefinitely. Hence it is called a climax community. It continues to remain essentially the same, if nothing occurs to upset it. But upset it can be. A change in direction of the prevailing wind, a heavy rainstorm, fire, or man's lumbering may sometimes start an erosion cycle in the forest, forming what is known as a blowout. A blowout such as this can take place anywhere in a forest with a sand base. This area has become desert-like again, even though it is just a short distance from the dark, humid forest floor. A blowout area over a period of many years will again go through an ecological succession. There will be the pioneer plants that hold the shifting sands. Then cottonwoods will usually appear. These again may be followed by pines. Pines in turn may give way to oaks, and the oaks, after many, many years, again may be succeeded by the beeches and sugar maples. The typical climax forest for this area.
Different climates and soils result in different successions. Compare the classic story of sand dune succession with that in your own community.